have a vertical asymptote, the horizontal asymptote, point of discontinuity, domain, and range. So the first one is in transformed form. We agree? Transformed form will not have points of discontinuity because it's transformed form. So that's out. Then we go based off of our denominator. It's 2x minus 1 for our vertical. It's the same thing we do for each one. It equals 0. Solve, move the 1 over, divide by 2, and we get x equals a half. Then, if it's in transformed form, you look at the back, and that's going to be your horizontal asymptote, which is y equals 4. Domain and range are really easy if you don't mess those up, because it's just what those don't equal. So the domain is x such that x cannot equal a half XER. Or y such that y cannot equal 4 YER. Okay, the second one you could say is in transformed form because the degree of the numerator is 0. And the degree of the denominator is 1. So as long as the degree of the numerator is 0 and the degree of the denominator is 1, it's in transformed form. We get negative 3x plus 1 equals 0. Subtract 1, divide by negative 3, we get x equals a third. Now, if your numerator is smaller than your denominator in your full fraction, it's going to be y equals 0. Or you could say because it's in transformed form, this is a plus 0 back. What's up, Marshall?
Minus 1.
Yeah, so then you divide by negative 3.
No, but the negative 1 gets negative 3x minus 1, not plus 1. So
boom, negative a third.
Yeah, I thought it was
negative,
correct.
and then it becomes negative. Yeah.
So then we have x such that x cannot equal negative a third XER. And then y such that y cannot equal 0.
Oh, you don't write frequencies?
Nope. That's a radical. All right. The next one, the degree of the numerator is the same as the degree of the denominator, and they're both 1. So I know that my vertical asymptote still comes from the bottom, so I get 4x plus 1 equals 0. So x equals negative a quarter. Now when they're the same degree, I just take the coefficients and make a fraction. So degree 1, so I'm going to get negative 7 over 4 as my y. I don't have a point of discontinuity because nothing cancels off. So my domain is going to be x such that x cannot equal negative a quarter XER. And my range is going to be y such that y cannot equal negative 7 over 4 YER. The next one I have to factor first. So when I factor the top, I'm going to get x plus 3x minus 3. When I factor the denominator, I'm going to get x minus 1, x minus 3. And then the x minus 3's cancel. So when they cancel, I immediately have a point of discontinuity at 3 and something. Because so is the opposite of that, right? How do I get that something? Well, I plug it back into the simplified form. So I'm going to get y equals 3 plus 3, which is 6, over 3 minus 1, which is 2. So you could say 6 over 2, or you could say 3, which would be more appropriate. So you just plug it into the reduced form. 3 plus 3 is 6, 3 minus 1 is 2, 6 over 2 is 3. Then what's left over gets you your asymptotes. So there is a rational still left over, so I take the denominator that's left over, x minus 1, put it equal to 0, so x equals 1. And then they're both degree 1, so I take their leading coefficients. It's 1 over 1, so I get y equals 1. Now the catch with the domain and range is the domain can't equal the x of the vertical asymptote and the x of the point of discontinuity. The range can't equal the y of the horizontal asymptote or the y of the point of discontinuity. So it's x such that x cannot equal 1 and 3, XER. And my range is y such that y cannot equal 1 and 3. The last one, when I factor it, what do I get on the top? Did anyone factor it out? 2x.
2x minus 1. 2x minus 1, x plus 4.
There we go. So the 2x minus 1's cancel. The moment that they cancel, you have a point of discontinuity at that solved. So at a half, right? Then how do I get the y? I plug it into here, the simplified version. I'm going to see. Half plus 4 is 4.5, or 9 over 2. Now, when it cancels off, I'm just left with y equals x plus 4, which is a line, is it not? So are there any asymptotes on a line? So neither of these actually exist. This one did because what was left over was irrational. This what's left over is a line. So my domain just can't be this, and my range just can't be that. So x such that x cannot equal a half, ICR. And then y such that y cannot equal 9 halves. Right. Then we go to the trig one. They give you a trig ratio, and then I ask you for cos A minus 30. So I know this is the same as cos A cos 30 degrees plus sine A sine 30. And I gave you sine of A. So sine of A is negative 3 over 7. Sine of 30 is a half. Cos of 30 is root 3 over 2. The only thing I need is cos of A. And how do I get cos of A? I have to sketch the triangle out and find the third side. So I have cast. I need where sine is negative and tan is positive. Sine is negative and tan is positive here. And this is sine your resume, so it's negative 3. R is 7. I need to solve for x, which is going to be negative because of it being in that quadrant. So I get x squared equals 7 squared minus negative 3 squared. X squared equals 49 minus 9. X squared equals 40. Square root, you get plus or minus. And it's going to be negative because it has to be there. And it's going to reduce to 40 reduces to 4 and 10. And when you take a 4 out, it's a 2. So you get minus 2 root 10. So cos, and this is triangle A, because this is sine A, this is triangle A. So we need to do cook extra rice. So cos of A is negative 2 root 10 over 7. Now when you use these sum and difference formulas of cos and sine, remember the great thing about them is they have common denominators. Every single time. If they don't, there's an oopsie. So we're going to go negative 2. Root 10 times root 3 is root 30, which does not reduce, over 14, plus negative 3 over 14, and then we just write them together. Negative 2 root 30 minus 3 over 14, and we're done, because unless you can take a number out of all three, you can't simplify it. So I'll show you what I mean. So unless you can take a number out of here, here, and here, which we can't do, we're done. What's that word? Yeah. No.
Why?
No perfect squares that 30 can break into.
Yeah.
What?
What?
Are you agreeing with me, or are you saying, yeah, there is?
No, I'm agreeing with you.
Oh, with you. It's agreeing with you.
What are you saying?
It's a dialect, most likely.
I know. We've heard.
Yeah, from, was it Detroit?
Okay. So, we have cos squared. Oh, I have a story.
Oh, no. What were you doing?
Okay, stop talking. It's just safer that way. Okay, so cos squared we replace with 1 minus sine squared x plus sine x. Move the 1 over, equals 0, which is where I started you guys with. Distribute, so we get 2 minus 2 sine squared x plus sine x minus 1 equals 0. So we get negative 2 sine squared x plus sine x. 2 minus 1 is a 1. And then because I like factoring with not a negative sign in front, I'm just going to move all the terms to the right-hand side. So when I move them over, just change the signs. So I get 2 sine squared x minus sine x minus 1 equals 0 if I add and subtract them to the other side. And what multiplies to give me, let m equal sine x. So I get 2m squared minus m minus 1 equals 0. 2m squared multiplies to give me negative 2, now it's going to be negative 1, is negative 2m plus 1m. Take out a 2m and I'm left with m minus 1. Take out a plus 1, I'm left with m minus 1. So I get 2m plus 1, m minus 1 equals 0. Need to solve for them. So this one's going to get me m equals negative a half. This one's going to get me m equals 1, which is sine x equals negative a half. And sine x equals 1. And it's limited between negative pi and 2 pi, but what I told you to do is always find the angles between 0 and 2 pi first, and then see if any coterminals fit, right? So sine equals negative a half here and here, which is at 5, no, it's pi over 3, so this is 4 pi over, oh, it's a 6. 7 pi over 6 and 11 pi over 6. If you check their coterminals, they're actually bigger than, no, they're not. They'll work. Well, looky that. If you check their coterminals, because negative pi goes to here, their coterminals, this one has a coterminal. If I subtract 2 pi from it, I'm actually going to get negative pi over 6. And if I subtract 2 pi from this one, I'm actually going to get 5 pi over 6, which both fit. So for just this answer, I get negative 5 pi over 6, negative pi over 6, 7 pi over 6, and 11 pi over 6. And then where sine x equals 1, it's just here, which is pi over 2. So the answer to this would be x equals negative 5 pi over 6, negative pi over 6, 7 pi over 6, 11 pi over 6, and pi over 2. And like I said, if you're writing the test on Tuesday at lunch, because you missed it, if you're writing the test on Tuesday, make sure that you watch the review podcast. Yeah.
Could you start over?
No, because you were talking about skip the dishes. I could hear you in the background. I could replay it. I'm not going to.
Do it, because I was following along.
No.
And then you turned in front of it, and then you went way too fast.
It's telling me I'm fat. That's what I'm taking from this.
I mean,
Rude.
you can take it how you want. But
See, now he's guaranteeing it. This is the problem.
The truth is, I could
So
not
we're going to
see
flip
it.
to the notes. Take a picture of it, Easton.
But I'm confused.
Take a picture of it.
Why did you get negative 2 sine squared x plus?
So, for example, the examples we did so far, all we did was we either took two equations and we added them, or we took two equations and we subtracted them, and if the equation behind the subtraction sign was more than one term, we had to remember to distribute, right? And then we collected like terms and we could go from there. The only big thing was that if we had a radical, we had to watch out that our domain would be restricted, right? Because we can't have a negative number under a radical. It has to be 0 or greater. So we're going to look at this one. And those all had x's. So this one here says, consider f of x equals x squared minus 7 and g of x equals 4x plus 5. Determine m of x equals f of x minus g of x, and then find m of 1. So we're going to do what we did yesterday, determining m of x, and we want m of 1. m of 1, when the number's in the bracket, it just means that's the value of x. Okay? So we're going to do m of x first. M of x equals f of x minus g of x. I'm just rewriting it. You don't have to. So m of x equals x squared minus 7 minus 4x plus 5. Now remember, we're minusing the whole 4x and the 5, right? So you either have to do it in one step, or you have to put it in brackets and remember to subtract the whole thing, right? Not just the 4. So we're going to get m of x equals x squared minus 7 minus 4x minus 5, and then we collect like terms. So m of x equals x squared minus 4x minus 12. broke down into m minus 6 and m plus 2, it's still fine, but you don't need to do that.
So are you not supposed to put the 1 as the x?
We will in the next step. So here it says determine m of x and then find m of y.
Okay.
Yeah.
That comes down to...
Oh boy, put on some glasses. You're killing me.
Sample hash.
I don't have any.
I've seen them.
Oh, you want to check my bag?
No, I really don't.
Exactly.
You
Okay.
have contacts, you ordered them.
They're probably not in
Can't
because
put them in.
exactly. I was gonna say it takes him too long.
It does.
See?
Then wake up earlier.
He can't. He has a first period spare.
He's
Not enough
allowed-
time.
Not allowed to wake up.
Not enough time.
Hey, just because
So
I-
m of 1 is what we have to find next. All that means is I rewrite this equation, but for every x, I'm going to put in a 1. So I'm going to get 1 squared minus 4 times 1 minus 12. And so then I keep writing the m of 1 down the side. M of 1 equals 1 minus 4 minus 12, which is negative 15. And you kind of already did this in polynomials, right? It was called remainder theorem. You would take the factor, you'd solve for x, and if you plugged it in, you'd get the remainder. You've kind of already done this. So what this really is now, you guys, what this m1 equals m of 1 equals negative 15 is on the graph of m of x. This is what this represents. M of x on the graph, there is a coordinate at 1 and negative 15. So all I did is, instead of taking the two equations, I found one coordinate. That's all we've done. So when we fill in an x, it just gives us the corresponding y on the new graph. What's that, Marshall?
1 minus 4 negative. Okay. Sorry.
We agree. All right. So this here, f plus g of 4. Now I told you sometimes they'll write that really weird with the f plus g and the 4 out. But you need to rewrite it as f of 4 plus g of 4.
It's 8 plus 1 negative 15.
What?
You have 8 plus 1 negative 15.
At 1 and negative 15. That's the word at. There's a desk right here. That's way closer for your sight.
I'm looking at it right here.
That's even scarier. All right. So we have f of 4 plus g of 4. So what is f of 4 at? F of x is the absolute value. G of x is the radical.
1.
F of 4 is at 1. So I go 1 plus g of 4. So when you have this, it means here's the x. What's the corresponding y? So g of 4, I go to 4, I follow it up on the g graph, and what's it at?
3.
3.
Oh, that's illegal.
No. So the answer is 4.
I thought it doesn't pass the vertical line test,
It's not asking if it's a function.
but it's not, right?
These two, yeah, that graph is a function. Those are two graphs. You don't do, are two graphs a function of each other? I don't know what. All right.
Eastern is smart.
He actually
My
is.
English grade reflects it too.
So, now what we actually found here is on the graph of this, on the graph of f of x, this is what we found. On the graph of f of x plus g of x, we found a coordinate. We just found one coordinate. The coordinate at, what was our x's? 4, because both of them had a 4, right? And then what was our y that we ended up getting? 4. So we actually got the coordinate off of the f plus g. We got one coordinate. It's at 4 and 4. That's our new coordinate.
That's the intercept?
No, that's the new coordinate of the graph of f plus g of x.
So how do we draw the new graph?
Or not. You would plot 1 point. It would be 4, 4. So here we have f plus g of negative 1. If I just ask you for that, That's the same as f of negative 1 plus g of negative 1. Now, f of negative 1, I'm going to use a different color. Bless you. F of negative 1. So I go to negative 1 and I follow it up to f, and it's at 4. Plus g of negative 1. So I go to negative 1, I follow it up to g, and I get 2. So this answer is actually 6. So on the f plus g graph, the f plus g of x graph, or we could say f of x plus g of x, it's the same thing. There's a coordinate at what? Nope, what was my x? Nope, what was my x?
1, 6.
You're getting closer, but still not
What
there.
are we doing?
What is the x?
What is, wait, for which one?
X is
For G.
negative 1.
Negative 1, and what was the y? 6.
That's what I said.
It is what he said, Miss.
I heard 6, negative 6, 1.
Well, I sit right next to
What,
him.
Yeah.
I'm confused what we're doing with these coordinates. Do we have to put coordinates?
No, I'm just proving the point that when we're actually finding this, that's what we're finding. We're finding the coordinate. Just one coordinate on the graph of f plus g.
Okay.
Very weird way to prove a point myself.
Oh, Easton.
Loud today, man.
So we have example number 6. Example number 6 wants us to sketch the entire graph of f minus g of x. So this is the same as saying it wants us to sketch the graph of h of x, which is f of x minus g of x. Now what I did in the previous examples is I actually found 2 coordinates on the graph of f of x plus g of x, 4, 4, and negative 1, 6, correct? Will 2 coordinates be enough to graph the whole graph? No. So I say the best way to do this is to start from left to right. Now, you can only draw a graph from where they both exist. So if we went back to the previous one, f of x plus g of x would have to start at x equals negative 5. Would x equals negative 6 exist on the graph of f of x plus g of x? No, because there's no g to add. Remember when we tried to add last time and there was no actual x value for one of the graphs? It was undefined. We didn't get an answer. So the graphs, when you add them, only exist where both graphs exist. Well, both graphs exist from negative 5 onwards. So if I actually ask for the domain of f of x plus g of x, my domain would be fast. It would just be x such that x has to be greater than or equal to negative 5, because that's where both graphs exist. So if I just asked you for the domain, it would start at negative 5 and go that way. If I wanted the range, you'd actually have to sketch the whole graph to get the range. The domain is quick. You just have to find where both graphs exist. And these both, so this one has an arrow, this one doesn't have an arrow, right? This one stopped, so that's why it starts here. But these both have arrows, so they go on forever, positive infinity to the right. So that's why it's greater than or equal to negative 5. Does that make sense? Okay. Well, let's look at these ones. I have arrows on the left of f of x, and I have an arrow on the right of f of x on the left. I have an arrow on the right of f of x, and I have an arrow on the right of g of x. So what would be the domain of f of x minus g of x?
XER.
Yeah, what would be the domain of f of x plus g of x?
XER.
Yeah. Because you can only add and subtract where they both exist. So the domain would be really quick to do for this, and I wouldn't have to do any work. Now, if I want the range, though, I actually have to sketch it. Okay? So the domain right off the hop of f of x minus g of x, the domain would be x such that XER. Because both graphs exist everywhere. The range, though, we're going to have to sketch it. So we work from left to right. We work from left to right, which might make the domain make more sense here. So I'm going to start where I can actually see both. Both these graphs have y values starting at negative 1, right? Would they keep going at x equals negative 2?
Yeah.
Yeah, but do I know what those are?
Yeah.
No. They're off the graph, so I don't know what those are. So I'm just going to start at negative 1. So this is my x. To get h of x, or to get my new y, I need to do f of x minus g of x, correct? So in this case, I'm going to have to do f of negative 1 minus g of -1 to get my new y. So what is f of -1 at? That's the g graph, and that's -5. What is f at? 1, 2, 3, 4. So f of -1 is at 4. And then I'm going to minus g of -1. G of -1 is at -5. So I'm going to go 4 minus -5, which is actually 9. So my new coordinate on the h of x graph is going to be at -1 and 9. I have one coordinate done. Now what if I do 0? 0 would be my next x, right? That they share in common. Does everyone see that? 0 is my next x they share in common. So I'm going to do 0 next. In order to get my new y, I have to do what it says here, f of x minus g of x. But I'm going to do f of 0 minus g of 0. F of 0, I go to 0 and I follow it up to my f. F of 0 is 3 minus sign. G of 0 is -4. Which is going to get me 7. So another coordinate on h of x is at 0 and 7.
We keep going?
Yep.
Until
Until you run out of...
that's a lot of space.
Yep.
So just 2 more.
No. So we're going to do 1.
0.
1 is my next x. And so I'm going to do f of 1 minus g of 1. F of 1 is 2 minus g of 1, which is -3.
There's a pattern, Miss Lepp.
Yes, because these are linear, but that's not always going to be the case.
But since it's the case. then
No,
it's
because
all-
we're practicing for times when it's not the case.
we're-
So 1, then the next x where it both exists is 2, so I can do 2. I'm going to do f of 2 minus g of 2. F of 2 is 1, g of 2 is -1. So I'm going to get 2. If I do 3, f of 3 minus g of 3. F of 3 is 0, g of 3 is -1. So it's 0 minus -1, which is 1. So my new coordinate's at 3 and 1. Something is wrong. This is a...
It shouldn't be 2, it shouldn't be 2 and 2, it should be negative. Whoa, what did you do here? It should be...
This should be a 3.
Yeah, it's a 3.
What did I
That's why
use
you
for
follow
numbers?
the pattern, Miss Lepp.
No. 2 is 1, and then -2, which is 3.
Done. Water on the ground.
And 1 and -2.
And this one's at 0 and -1. There we go. Which is 1. And then you're going to get... Now, because these are linear, a linear minus a linear, let's think about it. If we do like x plus 6 minus 2x plus 7, we're going to end up, when we collect like terms, we're going to end up with a linear, right? If we think about it. So if you can see a pattern happening and you know it's a linear and a linear, that's fine. But if it's like a quadratic and a linear, it might like work its way up like this and then at one point curve and come back down. So you can't just assume it's going to make a straight line and go based off of that. So if I go to sketch my new one, I'm going to do 4, f of 4 minus g of 4. F of 4 is -1 minus g of 4, which is 0, so I get -1. So I get 4 and -1. So if I went to plot this, I can't actually plot all of them because this isn't big enough. But I can plot what I can see on here. So I have like 1 and 5. Wow, this is really terrible. 1 and 5. 2 and 3. 3 and 1. 4 and -1. And then 5 is going to be -2, 5 and -3.
5 isn't.
Now,
Hold on.
5 and negative 3.
3 and 1, 4 and negative 1. Okay.
Yeah. So what is my range of this one? I had to actually sketch it to get the range. Y arcs just discoing, right? So the domain I can get by saying where do the two graphs both exist. But the range I actually have to sketch it. And when I sketch it, I see it's Y arc. Now this is another type that they can ask. So in order to sketch a graph, if you're adding and subtracting, you literally have to work your way from left to right on your x values. So -2, -1, 0, 1, 2, 3, 4, 5, 6, and then use the equation to get your new y. Okay? The last type of thing they can ask is example 7. So we've been finding h of x the whole time, right? And I've been giving you f and g and making you add them. We agree? But now I'm going to give you f, give you h, and make you find g. So the formula is h of x equals, and remember if it's written weird like this, f plus g of x, we're going to rewrite it as f of x plus g of x, and we're going to fill in what we know. We know h of x is x squared plus 5x minus 2. We know f is 3x minus 4. And then we're going to add g of x. Now, just like any other time, if we're missing something, we just need to isolate it, correct? So how am I going to get g of x by itself? Subtract. So I'm going to subtract 3x, and I'm going to add 4. So I'm going to get x squared. 5x minus 3x is plus 2x. Negative 2 plus 4 is plus 2 equals g of x. You guys try B.
Quotients functions.
We do them on Monday.
So we're done. Is the homework at the bottom of the page?
I'm not assigning all of that.
Yeah, you should not assign any.
You, all of it.
I thought it was yesterday's right now.
Shocking. Which part of yesterday did I assign? I don't even remember. 1 and 2?
1, 2, 4, and 5.
What?
8 questions.
1, 2, 4, and 5.
1, 2, 4, and 5.
I think.
Yeah, I haven't posted. It's posted on Google Classroom.
You also did
1 and
6.
2 are B and D, and then there's
4 and 5.
Yeah, also 6 and 7.
That's not true. I didn't do any graphing ones, but nice try. So page 483.
Unless it was within the maximum.
That's not true. You just said you're doing them. So I want you to do number 3.
Where did you do it?
No, you didn't.
Ah.
Because I haven't made you fill in yet. 7. 8 is extremely important that you can do. It's one of those, just like we did. So I give you 2 graphs. I give you a linear, and then I give you an absolute value in a linear. And I make you actually sketch f plus g, f minus g, g minus f. So you're going to get quite a few graphs from this one. And then,
Why? It's useless.
10, I just want you to do B and C.
This left question.
For 8, I want you to do B, because we already did a linear, which is fine. I want you to do 8B, but there are 3 parts, so you're going to get 3 graphs, the 1, the 2, and the 3 graphs. So 8B is going to involve 3 graphs. One of them is going to be f plus g, so you go through, make a table of values, do what we just did for f plus g, then one for f minus g, then one for g minus f. Number 7 is a matching. And number 3, I just want h of 2, m of 1, p of 1. So you're just going to do, those are really quick. And honestly, I gave you 30 minutes. If you sit down, that will be done before 30 minutes. So plenty of time. I was going to move on to product and quotient, but I decided not to.
Thank you.